Hi, my name is Ndidi, and I'm here to talk to you about α-1 antitrypsin deficiency, a genetic disorder that affects the lungs and livers of its patients. In order to understand the nature of this disease, we must first understand the term genomics. Genomics is the study and analysis of a whole organism's genomes. Genomes are the entire genetic makeup of a molecule or organism. By studying the genome of SUBTITLES, the gene that causes this disease and its mutations, we've gotten a much clearer view of α-1 antitrypsin deficiency and how the different genotypes affect people. SUBTITLES is one of the many genes manufactured on the Q arm of the 14th chromosome in the body. Chromosomes are a megastructure that compact thousands of genes into a thread-like structure. Humans have two pairs of 23 chromosomes with a short arm called P and a long arm called Q. Here, I've mapped out the three most common genotypes of the α-1 antitrypsin deficiency. We have the wild type or normal genotype, also known as medium, and the two most common disease genotypes, the slow genotype and the very slow genotype. In the slow genotype, there is a single base pair substitution that causes one DNA base pair to be changed. A guanine turns into an adenine, causing a detrimental effect on the α-1 protein by changing the resulting amino acid and causing the protein to fold incorrectly. The very slow genotype is the most common. Where there should be an adenine molecule, it switches to a thymine molecule, but this has a more detrimental effect. You may be thinking, great, but what does a bad protein even do? Well, let's talk about what a good protein does. α-1 antitrypsin is created in the liver. After this, it gets shipped off to the lungs. What's in a name? Anti means opposed to or against. α-1 is anti-serine proteases. A protease, like trypsin, is an enzyme that breaks down proteins in the digestive tract. It achieves this through a process called hydrolysis. But α-1 doesn't just stop trypsin from working. Its main target is a protease known as neutrophil elastase. But elastase isn't necessarily a bad protein. Neutrophil elastase is responsible for producing mucus during infection, which prevents tissue from drying out. It also propagates the inflammatory response, which can fend off foreign invaders and heal injuries. However, when unchecked, elastase destroys the elastin in lung cells, leading to the destruction of those alveoli. With α-1, we can stop this from happening. But when we are deficient in this protein, our lung cells face destruction. α-1 deficiency can cause secondary lung diseases like chronic obstructive pulmonary disease, COPD for short, and emphysema. COPD is a chronic inflammatory lung disease that causes obstructed airflow from the lungs. Symptoms include breathing difficulty, cough, mucus production, and wheezing. Emphysema is a lung condition that causes shortness of breath. In people with emphysema, the alveoli are damaged. In the liver, problems can arise too. When abnormal proteins are made, they become trapped into the liver instead of being released into the blood. This buildup of α-1 can damage the liver, developing conditions such as liver cirrhosis, jaundice, and abdominal swelling. You may be thinking, who actually suffers from α-1 antitrypsin deficiency, and how is it inherited? Although anyone can suffer from this disease, people of European descent are affected the most. α-1 affects approximately 1 in 1,500 to 3,500 individuals with European descent. The highest proportion of inheritance comes from Iberia, Northern Europe, and Saudi Arabia. The inheritance pattern of α-1 is known as codominance or mixing. If you inherit two bad alleles from both of your parents, you will show symptoms of the disease. If you have one good allele and one bad allele, you may have some mild symptoms or none at all. With two good alleles, you will not show any sign of the disease. So you may be wondering, how could you achieve optimum functionality with α-1 antitrypsin deficiency? The first step is to get diagnosed. Besides a doctor, you can use a lot of genetic tests to find out if you are a carrier or positive for α-1. 23andMe is one such example. In fact, up to 90% of people with α-1 have not been diagnosed for this disease. It is important for α-1 patients to not smoke. The average lifespan of an α-1 patient who smokes is only 60 years old. Many patients with α-1 may not be able to live in urban areas as pollution can alter lung function. Unhealthy diets also contribute to low functionality. α-1 patients should not be smoking. If they can, living in areas with minimal pollution is also important. Healthy diets and low-intensity exercise can help achieve optimal functionality. Although there is no cure for α-1, there are therapies available. Augmentation therapy is the current therapy for lung-related problems, and this involves the use of injecting blood serum from healthy donors to increase α-1 levels in the blood. This therapy is ongoing and lifelong. In the most extreme cases, a patient may need a lung or liver transplant from an eligible donor. What better way to end this video than to talk about how the pandemic may affect people with α-1 antitrypsin deficiency. Those with α-1 are considered to be at high risk for contracting COVID-19 because of their lung weakness. It is important for people with and without α-1 to wear masks, wash your hands, socially distance, and stay at home when they can. If we do this together, we can curb the spread of this disease. And this is where the video ends. Thank you for watching. I hope this video helped you learn something new.